Hello everyone, today in this video we are going to talk about permittivity and dielectric constant of a medium, and after this video you should be able to define permittivity and dielectric constant, and you should be able to calculate the electrostatic force between two charges when kept in different media. To understand permittivity, let's take an example of two friends. Suppose they are angry with each other and they want to fight with each other. Suppose they are in front of their principal. That time they cannot fight because you can see principal is strict. So in this environment or medium they cannot fight. But if they are in front of teacher who is not that strict, then they can have argument. They cannot fight, but still they can argue. So as you can see, the environment changes, their behavior or interaction is also changing. So suppose now they are in front of their friends, so that time they can fight easily because this medium will allow, and this medium with the principal will not allow. This medium with a lenient teacher may allow up to some extent, but fighting is allowed in this medium. Similarly, the interaction between two charges depends on different medium. Like in air, there will be some force between them, but if you take them in water, same set of charge, the force will be different. And if you take them in another medium like rubber, then the interaction will be different. So you can see the force is decreasing or increasing depending on the medium between them. So medium is also responsible for the force between them. So we can say different media permit two charges to interact in different way. So different media has different value of permittivity. So permittivity means property of medium that affects the force between 2 point charges, and permittivity is denoted by epsilon, and for free space we denote it by epsilon naught. Epsilon naught means permittivity of free space, and different medium has different value for this permittivity. And next is relative permittivity or dielectric constant. Relative means we are comparing the permittivity of that medium with something else. Suppose FVAC is the force between these two charges when they are kept in vacuum, and FW is the force between same two charges when they are kept in water. So if you want to know what is the dielectric constant of water or relative permittivity of water with respect to vacuum, then we divide this force in vacuum divided by force in water. So suppose you want to know the dielectric constant of any medium, then we divide the force between these two charges in vacuum by the force between these two charges in that medium. So this is the definition of dielectric constant or relative permittivity. So this is the formula: force between two charges in vacuum by force between same two charges at same distance in that medium. So this is the definition which I have already explained. You can pause the video and copy the definition. Now we will derive the formula for relative permittivity. So as we already know, dielectric constant, and this is not K, this is kappa. There is difference between K and kappa, so you while writing you make sure that they look different. So dielectric constant is F vacuum by F medium, and we already know F vacuum is 1 by 4 pi epsilon naught. Epsilon naught is permittivity of free space, and F medium is given by this expression, and this is epsilon medium EM. So this is the permittivity of medium. Now if you put the value, then this part will get cancelled. Now you are left with this. Now when you bring this up, you have to reciprocate it. Then this 4 pi and this 4 pi can be cancelled out, and you are left with dielectric constant is equal to permittivity of medium divided by permittivity of free space. So this is the another definition. First we have defined it in terms of force. Now we are defining dielectric constant in terms of permittivity. Relative permittivity of a medium or dielectric constant of a medium is the ratio of absolute permittivity of the medium to the permittivity of free space, and it is denoted by kappa or epsilon m. So by mistake I have written R, you can write m. And dielectric constant is a ratio. You can see force by force, Newton will get cancelled, and there will be no unit for dielectric constant. So now we will solve one question on permittivity. So dielectric constant of water is 81, and we have to calculate the permittivity of water. So dielectric constant kappa is given 81, and epsilon naught we already know, 9 into 10 to the power minus 2 coulomb square per Newton per meter square, and the permittivity of medium is question mark, we have to find. So we already know kappa is em by E0. So now you multiply this to this side and you are left with this. Now em is equal to k epsilon naught, then we'll put the values. Now you are left with 7.29 because you'll get 2 zeros from here, so this minus 2 will go away, and the unit for permittivity is coulomb square per Newton per meter square. So this is the final answer. So now next question, two insulated charge copper A and B have their centers separated by distance 50 centimeter in water. So they are kept in water and charge of each sphere is this much. We have to find the electrostatic force between them. So out here charges are given, distance is given 50 centimeter, centi means 10 to the power minus 2. So this 0 will take 1 minus down and it will be 5 into 10 to the power minus 1 meter, and our dielectric constant is 80. K is equal to epsilon m by epsilon 0. So we need epsilon m. So epsilon m is dielectric constant into epsilon naught. So we know force between two charges when kept in medium, then we can write this expression. So out here instead of epsilon naught we are writing epsilon m for medium. Now for epsilon m I can write dielectric constant into epsilon naught 0. So now I'll take this out. Now this is k, 9 into 10 to the power 9. Now I think this is the same step. So now I'll put the value of dielectric constant is 80, and this is k, 9 into 10 to the power 9, and the value of charges divided by distance square. Now when you solve this, I'm taking all the numbers together and taking the power together. Now it will become this, and this minus 2 will go up and it will become plus 2. Now next step, again this 2000 is 2 into 10 to the power 3. So from here when you divide this you'll get 190.1, and this 3 will go up and it will be 10 to the power minus 3 minus 3. So it will be minus 3 is 6. Now from here I am shifting this point out here, so I'll get plus 2. So your force is 1.9 into 10 to the power minus 4 Newton. So I think this is the end of the video. I would love to hear your opinion about my video, so please write something in the comment section. Please don't forget to like the video. Yeah, you can like it now, and please subscribe my channel if you are new to this channel, and you can share it to your friends. And out here I'm giving my phone number. If you need help in any topic, you can WhatsApp me. Thank you.